Unit 5, Learning Target 4, solve a system of equations using elimination. So we already learned how to do two different, like how to solve it for two different types, where we would graph it. So there's my graph. You graph the one line, you graph the other line where they intersect. That would be the solution. And then the second way would be substitution, where it's like y equals 2x and then 2y plus x equals 7, and then you would plug this in for that y, and then you would solve. So now we're going to do it by elimination. So elimination method, if you remember in the method that we just did in Learning Target 3, some of it wasn't always set up as like y equal, like both of them, it wasn't y equals something and x equals something. This is normally where you'll use elimination. Elimination works really well only in certain cases. So again, if you already have it as like a y equals or an x equals, I would still probably use the other one, but this will work very good. So our goal for elimination is, if you can guess, we're going to eliminate one variable. So we're going to try and get rid of a variable. So I'm going to show you with examples what I mean by this. So we're going to start with this problem. Whenever you have problems and you're using elimination, you want them to line up like with according to variables. So my x's are in a line, my y's are in a line, and my numbers in a line. You see how none of these are set like x equals 7y plus 5. So it would be very hard, or it would be a lot more work to use the other method. So what we want is, in the easiest cases of these, we want to look at our x's and our y's and see if we can cancel any of them out. So I look, they're both a positive x, that's not going to cancel out. This one's a positive 7y and this one's a negative 7y. So if I were to add them, they would cancel out. So whenever we're doing elimination, maybe you also want to put this in here, whenever we're doing the elimination, we add them together. We're always going to add these together. So if I add these two, and I don't need to change anything, x plus x is 2x. 7y plus a negative 7y would give me 0y, and this is where that elimination is. I'm eliminating my y here. So now I'm getting 2x to equal 13 plus 5, what is that, 18. So now I'm just solving for x. I divide by 2, x is going to equal 9. Now that I found x, I can plug this into either equation and get my answer. I'm going to put it in the bottom one just because I like the number 5 better than 13. So it was x minus 7y equals 5. Well, this is now my x value. I'm putting it in there. So now it's 9 minus 7y equals 5, and I'm solving for y. Minus 9, minus 9. Negative 7y equals negative 4. Divide by negative 7. Divide by negative 7. Y equals 4/7. So if I want to, I could say my answer is 9, 4/7. That's my xy coordinate value. All right, so I would pause this because I'm going to erase this. Pause it if you still need to see it. I'm going to move on to the second one. Okay, this one's a little harder. They're lined up already, my P's, my Q's, and my numbers. But if I'm looking at this, nothing right away cancels out. Just like right here, this was a positive 7 and negative 7. I know they're going to cancel out when I add them. So what I have to do to eliminate is I have to multiply something to get ready to cancel out. So when I look, my first thing that I always want to look for is just the variable by itself, because that's then indicating that there's a 1. Like this is 1q. I could easily multiply this whole thing by 3, because this is a positive, this is a negative. If I multiply this by 3, this would be a minus 3. So that's what I'm going to do. I'm going to multiply the whole thing, though. I can't just multiply q. I have to multiply the whole thing. So that's like distributing. I'm multiplying everything by 3. So 3 times 5p is then a 15p. 3 times negative q is a negative 3q. And 3 times 11 is 33. So now I'm using this equation up here and this equation down here, and I'm not using this one anymore. And so now if I look, I have a plus 3q and a minus 3q that I know will cancel out. So now when I add these, 2p plus 15p is going to give me my 17p. 3q minus 3q, these are now going to cancel out, so I got rid of my q's. What is this going to give me? 18, 1, 3, 4, 5? No, yes. 3, 4, 5, yeah, 51. So then we divide by 17, and this cancels. P equals, I'm not doing that right now, I'm not going to lie. So then to find out what Q is, I take this value and I plug it back in. You take that value and I plug it back in. Okay, so here's the hardest kind of problem. Again, nothing matches up to subtract. There is no single variable by itself. They all have a coefficient. This is a 2, that is a 4, that's 7, that's a 3. So then what I want to do is I want to look at the two variables that go together where one's positive and one's negative. Well, these are both positive, so I'm not going to be able to cancel them without multiplying by a negative. One's positive here, one's negative here, so this is going to be the term I want to cancel. Because when I add, they'll cancel each other out when I make them the same. So to make them the same, I can multiply them by something they both go into. The smallest number that they both go into happens to be 12. So I'm going to times this whole thing by 3 and this whole thing by 4. So my new top one, 3 times 2 is 6x plus 12y equals 40 times 3 is going to be 120. And then when I do this one, so first this was that one, now I'm going to do the bottom one. 4 times 7 is 28x. 4 times a negative 3y is a negative 12y. 4 times 4 is 16. So now I can add these because here's my two numbers that will be eliminating my y. I'm eliminating the y. So 28 plus 6 I'm adding is, what is that, 34? No, 28. Yeah, 34. I don't know. And then, what am I doing? Oh, yeah. 120 plus 16 is 136. We divide by 34. And so we're going to get x. So I'll do this whole problem out since I didn't do the last whole problem out. So what 136 divided by 34. So we're going to get x to be 4. Now that I know what x is, I plug it back into any equation to get y. Let's see. I don't feel like dealing with 40, so I'm going to do it in the bottom equation. So 7 times now 4 minus 3y equals 4. So 28 minus 3y equals 4. So I actually should have probably picked the top one because then I wouldn't have negative numbers. Minus 28 minus 28. So I get negative 3y equals negative 24. When I divide by a negative 3, I get y to be 8. All right, so here are our special cases. Again, nothing matches up, so I'm going to have to multiply something. I look then for my positive negatives. Here's a positive, here's a negative, here's a positive, here's a negative, so it doesn't matter which one you want to multiply. This one, though, I can see if I multiply this top by 2, that's going to give me a 10. So that new problem is now going to say, so this new one is going to be down here. 10x plus 6y equals 20. So now I can add these. 10x, negative 10x plus 10x, that's going to cancel. But if I look here, negative 6y plus 6y, that's also going to cancel, which means I eliminated both of my variables, leaving me with just 0 on this side. Negative 12 plus 20 is an 8. We know that 0 does not equal 8, so this would be no solutions. And I'm guessing you can probably guess what this one is, but let's do it anyway. Negative 3x plus 4y equals negative 7. 6x minus 8y equals 14. I see that if I multiply this top one by 2, it'll give me a negative 6 to cancel out. So let's look at that. Negative 6x plus 8y equals negative 14. So now I can add. My x's cancel, my y's cancel, leaving me with 0. 14 plus a negative 14 is 0. 0 does equal 0. That is true. So this would be infinite solutions. So again, before class, solve this system of using elimination now. So you're doing what I just did. Again, if you don't get this, we're going to practice this a lot in class. So that way we're like positive you know what's going on.